Hiten. The Hiten spacecraft, given the English name Celestial Maiden and known before launch as MUSES-A, part of the MUSES Program, was built by the Institute of Space and Astronautical Science of Japan and launched on January 24, 1990. It was Japan's first lunar probe, the first robotic lunar probe since the Soviet Union's Luna 24 in 1976, and the first lunar probe launched by a country other than the Soviet Union or the United States. Hiten was to be placed into a highly elliptical Earth orbit with an apogee of 476,000 km, which would swing past the Moon. However, the injection took place with a delta-v deficit of 50 m/s, resulting in an apogee of only 290,000 km. The deficiency was corrected and the probe continued on its mission. On the first lunar swing-by, Hiten released a small orbiter, HAGO Romo, into lunar orbit. The transmitter on HAGO Romo failed, but its orbit was visually confirmed from Earth. After the eighth swing-by, Hiten successfully demonstrated the aerobraking technique on March 19, 1991, flying by the Earth at an altitude of 125.5 km over the Pacific at 11.0 km/s. Atmospheric drag lowered the velocity by 1.712 m/s and the apogee altitude by 8,665 km. This was the first aerobraking maneuver by a deep space probe. After the ninth lunar swing-by and second aerobraking maneuver on March 30, 1991, the primary mission of the probe was concluded. Edward Bell Bruno and James Miller of the Jet Propulsion Laboratory heard of the failure of the HAGO Romo orbiter and helped to salvage the mission by developing a so-called ballistic capture trajectory that would enable the main Hiten probe to enter lunar orbit. Bell Bruno had been working on numerically modeling low-energy trajectories, and heard of the probe's problems. He developed a trajectory solution and on June 21, 1990, sent an unsolicited proposal to the Japanese Space Agency. They responded favorably, and later implemented a version of the proposal. The trajectory Bell Bruno and Miller developed for Hiten used weak stability boundary theory and required only a small perturbation to the elliptical swing-by orbit, sufficiently small to be achievable by the spacecraft's thrusters. This course would result in the probe being captured into temporary lunar orbit using 0 delta-v, but required 5 months instead of the usual 3 days for a Hohmann transfer orbit. This was the first time a satellite had used low-energy transfer to a Moon orbit. On October 2, 1991, Hiten was captured temporarily into lunar orbit. After that, Hiten was put into a looping orbit which passed through the L4 and L5 Lagrange points to look for trapped dust particles. The only scientific instrument on Hiten was the Munich dust counter, and no increase over background levels was found. On February 15, 1993, Hiten was placed into a permanent lunar orbit, where it remained until it was deliberately crashed into the lunar surface on April 10, 1993 at 34 degrees 18 minutes south 55 degree 36 E/34.3 degree S 55.6 degree E/-34.3, 55.6, between the craters Stevinus and Fern Rias.